In this video, we're going to discuss the concept of classes and objects in a little more depth than we've gone so far. An object is a very important concept in object-oriented programming. Most programming languages that we use, in modern development are object-oriented languages. Java is an object-oriented language. So we're going to create programs that are made of objects. And it's important to kind of understand what an object is in order to actually use those. In programming, an object is a software component that exists in the computer's memory. Typically, programming objects perform some kind of specific task. And those two capabilities or tasks that objects perform or can do, one of them is storing data. And any data that is stored in an object, we call that a field. Data is stored in a field. And they can perform operations. So the operations that objects can perform, in Java, we call those methods. Have we seen objects before? We have learned about objects in this course already. Here's a couple of the ones we've talked about. If we want to read input from the keyboard, we would use a scanner object, right? We create a new scanner object, and then we can use that object to perform some tasks, right? Like it says here, we are performing operations using the scanner object, for example. Also, if we want to generate random numbers, we could use a random object to generate those numbers. When a program needs the services of a particular type of object, we need to create the object in memory, and then we can use the methods that are from that object however we need to. The next line method from scanner, for example, or random.nextInt. Those are methods that belong to those objects. In order to really understand how we use objects, though, we need to understand what a class is. So before we can use an object, like we've discussed, we need to create it in memory. Well, before we can create an object in memory, we need to have a class for that object. All a class is code that describes an object. It describes the data that the object can hold, or the fields, and it also describes the actions that an object can perform, or the methods. If you remember back here, the two capabilities of objects, right, storing data and performing operations, those two things are described in a class. And the best way to think about a class is as a blueprint. So if we want to think about the class like a code blueprint, we're going to use that blueprint to create different objects. Very similar to the blueprint of a house, right? The blueprint itself is not a house, but it does describe how to build a house, what the house is going to contain, the different rooms in the house, all of that stuff is part of the blueprint. When we use a blueprint to build a house, we could say that we are building an instance of the house that is described by that blueprint, right? We could also build several houses from the same blueprint, each house being a separate instance of the house described in the blueprint. The same is true for objects and classes, right? I'm going to replace this, right? When an object is created from a class, we are building an instance of that class. We can also build several objects from the same class, each object being a separate instance of the class. So what does that mean? Well, a class describes how an object will be built, right? Or constructed. We can use the same class to build several different objects. Are classes and objects the same thing? No, they are not. This is really important. It trips a lot of people up. They think that a class is an object. There are two different things, right? In the blueprint analogy, we said that a blueprint is not the same thing as a house. Similarly, a class is not an object, but it is a description of an object. And we discussed already, right? The class describes the data that an object can store, as well as the actions that an object can perform. When the program is running, we can use the class to create as many objects as we need in memory. Each object that we create from a class is called an instance of that class. Haven't we used classes? We actually have used classes before. Remember in IntelliJ, when we click on our source file to add a new file, we are adding a new class, right? We've used classes a little differently than the purpose that I'm describing here. Right now we're talking about classes that are used to create objects. We've been using them as a sort of container for methods, right? We haven't been creating objects from classes that we write. We've been creating objects from pre-written Java classes like the random class or the scanner class. All of the programs we've written so far have had a class containing a main method and maybe a few other methods. But moving forward, we're going to discuss how can we create or how can we write classes ourselves that we can use to create objects from those classes. I want to refresh on primitive variables versus objects. Remember that primitive variables are variables that can hold only one value at a time, right? Byte, short, ints, booleans, all of those things are primitive variables. Object variables, if you remember, store a reference to an object's location in memory. And we call those reference variables, just to remind you that that exists. So if you remember, when we create an object, how we actually do that in code, the first thing we want to do is declare a reference variable, which we do here in this example. My reference variable is named rand, and its data type is a random object, right? So the rand variable is going to reference an object of the random class. Which object is it going to reference? Well, over here is where we describe that. It's going to reference a new random object. And then after we create the object, we can use the reference variable to work with it, right? So we say rand.nextInt. Same thing with scanner, right? If this was scanner KB, we would use kb.nextLine or kb.nextDouble, right? We use the reference variable to work with the object that's being referenced. So let's talk about how to read a simple class. I have the source code for this class, and I will pull it up. But let's discuss what we're going to look for here. We have a class named rectangle. Every object that we create from the rectangle class will be able to hold data about a rectangle. And specifically, it will have these items here. So I'm going to show the code. Actually, I'll read this first, and then we'll show the code. So our rectangle class says that all rectangle objects have a length and a width. These are our two fields. If you remember that fields were the data that objects can hold. So we have two types of data that a rectangle can store, its length and its width. The rectangle can also have the following methods, or it can perform the following actions, right? We can set the length of the field. We can set the width of the field. We can get the length and width of the fields, and we can also get the area. So getArea will return the area of the rectangle, which is just length times width, right? So let me go look at our code really quick. So this is how that would look in code, right? My two fields are here. And we'll discuss private here in a second, but these are just variables, right? Length and width, they're both doubles. And we'll discuss what this means here in just a second. We're going to move past these. We'll come to this later. But setLength is a method that I have, or an action, right? Public void set length. I have one parameter. And what this method does is if I were to call rectangle.setLength and I were to pass a number here, it would change the value of this rectangle's length attribute or field, right? Same thing with set width. Get length and get width will return the value of those fields. So let's say in my main method in my other Java file, I wanted to see, okay, what is the length of this rectangle object? Well, I could just say rectangle.getLength, and that would tell me what the length is, right? I'm returning that value. GetArea will just return length times width. So let me go back here. Notice rectangle, the rectangle class, is in the same folder as wherever my main method is going to be. So I'm going to put my main method in a separate file called object practice, and we'll come back and create some objects in here in a second. But rectangle is in the same file as object practice. That's very important. It is critical that your class files are in the same folder as the file that contains your main method. And the reason for that is Java compiles code in such a way that requires those be in the same folder, at least for this course. You can use something called packages, but that's kind of outside the scope of this class, so we're not really going to discuss packages here. For now, just make sure they're always in the same folder. And in IntelliJ, that's very easy, right? We just right-click our source folder, we add a new class, and it's going to be in the same folder no matter what, as long as we're right-clicking source, right? So it's pretty easy to make sure that happens in IntelliJ. Oops. So let's change gears a little bit and talk about UML. And actually, I want to show you how to create an object really quick. So rectangle, right? This is a class that describes something, right? What does this class describe? Well, it describes a rectangle. We have a length, we have a width, we have all of these things that the rectangle can do. To create an object, all I need to do is say just like we do with random, right? Notice I don't have to import anything because I've written the rectangle class. It's something that I wrote. And it's in the same folder as the object practice file. So I can create objects of the rectangle class. Well, how do we use the methods of the rectangle class? The exact same way we do other object methods we've used before. I can say r.setLength. Maybe I'll set that to 10. I'll set the width. Maybe I'll set that to 15. And maybe I want to look at the area. So I could just say system.out.print r.getArea. And this should show me the length times the width, right? And we'll see that it does. So really the only new thing that we're talking about here is how to create our own classes instead of using ones that already exist, right? Let's use random, for example. If I want to use the random class and create random objects, I would need to import java.util.random. Then I could come down here and say rand is going to reference a new random object. And then I could say, int x receives rand.nextInt. So really there's no difference in what we already know, except we don't have to import classes that we write, and we just need to learn, the ins and outs of writing our own classes, which we're not going to hit too hard. I just want to show you how to read a class mainly this week. We may create some simple classes, but I just want you to kind of know what's going on in a class, and then we can discuss writing more complex ones. All right. So let's talk about UML. And we discussed UML way back several weeks ago toward the beginning of the semester. But UML diagrams are very helpful when you are reading a class or when you want to create a class. UML diagrams can be very useful. And UML, again, stands for Unified Modeling Language. That provides a very standard set of diagrams and syntax for depicting a object-oriented system, and specifically classes, right? So UML is a very basic layout. It's a box with 3 sections. The very top box, or the very top section, is where the class name would go. The middle section is where any fields are listed, and the bottom section is where any methods are listed. And we discussed diagrams.net and Lucidchart at the beginning of the semester. So if you were to make UML diagrams for an assignment, you could just use those. And I'll show you how to do that here in a second. So let's get more specific, right? The rectangle class that we just looked at, let's look at a UML for that class. Right, so the top section, like we said, was the class name, which we know is rectangle. And we know that rectangle had 2 fields, right, length and width. And we know that it had several operations or methods, which are listed here at the bottom. Let's assume that we didn't have the source code already. If we were to use this before we started coding, if we had access to this UML, it would be pretty simple to go in and start writing code, right? We would say, okay, public class rectangle, I have 2 fields, and I know that I'm going to have these methods. So UML is very useful for helping you set up kind of the structure and skeleton of your code. So let me look at something really quick, yeah. So let's talk about accessors and mutators, which is just a fancy word for something called a getter and a setter. And I'm going to write this down. It's down here, but I'm going to write it up here. I'm going to try to write it, at least. Okay. So it's very common to make all fields private. That's a very common practice in programming. So notice in rectangle, my fields are all private. And the reason for this is maybe we don't want anything that we create a rectangle object, maybe we don't want to directly be able to modify the length and the width. So we're going to make these private. Well, how can we change the length and width of the object, and how can we read the length and width if they're private? Well, we use that with using an accessor and a mutator method. So an accessor method is just a fancy way of saying it's going to get a value from the field, but it's not going to change it. We call these getters sometimes, and they're called accessor methods because all it's doing is accessing the value of a field, but it's not going to change it in any way. Methods that store values in fields or change the field in some way, we call those mutators. They are mutating the value of a field. We call these setters sometimes because they're also setting something. They're setting the value of a field. So in our rectangle class, getLength and getWidth are our accessors or our getters. SetLength and SetWidth are our mutators or our setters. Right, so let's look at getLength here. We can see all this method is doing is it is accessing the value of the length field. It's not changing length in any way. It's not modifying it. It's just accessing it. It's returning it. SetLength, on the other hand, we'll see has a parameter here, it is going to change the value of the length field to whatever that parameter value is. It is mutating it or setting it, right? So this is a mutator. This is an accessor. Let's talk about private and public a little bit more. Also, before we do that, your fields in a class that describes objects, your fields need a access specifier, which we talked about with methods, right? And we said most of our methods for now will be public, right? Your fields need an access specifier, either public or private, but like I said, 99% of the time you want these to be private for your fields. Notice that our methods in a class that we're going to use to create objects, right? The rectangle class is specifically used to create rectangle objects. So notice that our methods here are not static, right? I don't have public static void set length. I just have public void set length. Static, and I think I have some information about static in the slides later, but for now, we only use static in Java files or classes that are not used to create objects, right? Like so far, what we've seen is something, I'll do something very basic like this. And I'll add another method here. Right, so this is kind of what we've seen so far. We've written classes. We are not creating objects of the classes we've written so far, right? I'm not creating an object practice object anywhere. We're just running this file, it's doing its thing, and it's done. So for files like this that we are not creating objects of, we use static on their methods. But for a file that we want to create objects of, if I want to create rectangle objects, I cannot have the word static here. So just an easy way to remember that. If you're creating objects of the class you're writing, don't put static. If you're not creating objects, put static. So let's go back to data hiding. Data hiding is one of the strengths of object-oriented programming. It allows us to hide internal data about objects that we don't want to be shown outside the class itself, right? So what that means is only the class itself can access and make changes to the object's internal data, right? So we can use data hiding by making the fields private and making the methods public. So what that means is my fields here are private. The only things that can change the value of these fields is if you go through these methods, right? If I want to change the length, because it is a private field, the only way I can do that outside this rectangle class is to use this method here, setLength. So that's kind of the basics of data hiding. In UML, we do have one more thing that we need to add, which is access specification. But I'm going to go ahead and set up just a very basic skeleton of our rectangle class. So here I'm here in diagrams.net. Down here at the very bottom, you'll see UML. And we have a bunch of options here. We're not really concerned with any of these in this course except this third one over here, which is just a class. So all I did was click class and I dragged it over. And now I can start working on it. So we said the top section of the UML was the class name. So I'm going to put that here. We said the middle section was for our fields. So my first field is length. And if you're using Lucidchart, I think there's little plus buttons here that you can use to add more than one. If you're using diagrams.net, this fifth option. It just says sorry about that. My headset died. Okay, so like I was saying, the fifth option here, the item attribute, we can just drag these over, and this lets us add more than one item to our UML diagram. So we only have two fields. My second field was called width. Right? And I had several methods, which I'm going to go look at to make sure I don't forget any. I have set length, set width, get length, get width, and a get area. So I have a setter and a getter for each of my fields, and then I have one more method called get area. So I'm going to go ahead and add those. I have 5 methods, so I'm just going to go ahead and add those in now. And then I'll just type out what they need to be. So my first was called set length. My second was set width. Then I had get length. Then I had get width. Notice I'm putting parentheses after these because they are methods. And then I had one called get area. Unfortunately, we have to add a little bit more to our UML to make it more descriptive so that we can write code easier from the diagram itself. So we didn't indicate which members of this class were private or public, right? I don't know from my UML, I don't know which of these fields are private or public. I don't know which of these methods are private or public. We actually can identify that in UML. And how we do that is we put a minus character before the name of the member to indicate that it's private, and we put a plus to indicate that it's public. That's just kind of the UML standard. So length and width we already know are both private, so I'm going to put a minus sign in front of those. And my methods, each of my methods I know is public, so I can put a plus sign in front of each of these methods. So now this is a little more descriptive, right? We have private length, private width, public sets, and public gets for my methods. There's even more we can add to our UML to make it even more descriptive than that. We can also show data types and parameters in UML. To indicate the data type of a field, we put a colon after the name of the field, and then we say the data type after the colon. So let's do that for our two fields here. So length is the name of the field. I'm going to put a colon after the name of the field, and then I'm going to put whatever data type length is, which in this case it is a double. I'll do the same thing here with width. My mouse is messing up. Okay. Methods are fairly similar, but they do have a little extra stuff we look at with those. So with methods, we indicate return types the same way that we do data types of fields. We put a colon after the method name and whatever type it's going to return. So if it's a void method, we would put colon void. If it's going to return a double, we would put colon double. So let's do that for our methods. So my setters are void methods, right? They're just going to set the value of a field and they're not really going to return anything. My getters are all going to return something. In this case, they are all returning doubles. Okay. And the last thing we can look at with UML is parameters. So we can see, does a method have a parameter? And what is the parameter? These work the same way as fields. do. We have the name of the parameter, a colon, and then the data type. They just go inside the parentheses of the methods. So setLength, for example, had a single parameter called len, which was a double, right? If we looked at our source code, setLength had a parameter called len. What data type is this? It's a double. All right. I'm going to stretch out this box a little bit so that it all fits. SetWidth also had a parameter called w, and it was also a double. So this is a complete, almost complete UML for the rectangle class, right? And you could see how if we didn't have the source code for this, just looking at this UML would make it pretty simple to go and start writing the code, right? Public class rectangle, private double length, private double width, public void set length, and we know the parameters. Public double get length does not have any parameters. And all that you would have to do at that point is just write the guts of these methods, right? What the methods are actually going to do. Class member layout. This is just kind of a programming style thing that I wanted to talk about. It's best practice or most common practice to put your fields at the very top of your class and then put your methods after your fields. So we do that in this rectangle class, right? I have my fields here, and then I have all my methods listed after the fields. And the reason for that is it follows the UML notation, right? The top section of the UML was the name of the class, the second was our fields, and the third was our methods. That's just kind of why it's the best practice to lay it out the same way in the source code. You don't have to do it that way. It's not required for your program to run or your class to compile. It is just a common practice. Whatever you choose, be consistent, as I always say. Personally, I like writing the fields first, so any code examples that I provide will have the fields listed first. Let's talk about constructors now. Constructors are deceptively simple. They can be kind of confusing to people, but really all a constructor does is it is a method of a class. A constructor is a type of method. It is automatically called when you create an instance of a class. So it's a method that's automatically called. Similar to the main method, right? When you run your program, the main method is automatically called. Constructors are kind of similar. Whenever we create a new object, it automatically calls our constructor methods. What are they for? What do constructors do? Typically, they describe how an object is going to be set up, right? So if we want to store initial values in our fields, we can tell them to do that. We can have our constructors do a lot of things. They typically are called, or they are called constructors because they help construct or build new objects. Some things about constructors that you need to know. They have the same name as the class. So a constructor method has the exact same name as the class. And they do not have return types. That's important. Constructors don't have return types, not even void. And the reason for that is they are not executed by method calls, right? I don't say rectangle.constructor, right? Whatever our constructor name is, it's automatically called. So we don't have return types for methods that are automatically called. And in UML, there are a lot of different ways people say you can show constructors. This is the way I do it. I just write it like any other method, but I don't put a return type at the end. So let's say I want a constructor, right, that says, okay, whenever I create a new rectangle object, I'm going to pass in two numbers. The first number will be the length, the second number will be the width, and what the constructor method is going to do is it's going to set my length and width fields to the values that I passed in, right? So if I pass in 5 and 10 when I create the object, the constructor will automatically set length and width fields to 5 and 10. We don't have to use the setLength method, which is what this constructor here is doing. Notice that I have a constructor up here. Again, notice they both do not have return types and they both have the same name as the class. So public class rectangle, my constructors have the same name as my class. And we'll discuss why they can have the same name here in just a second. But this constructor takes 2 arguments and it will set the fields of the object to whatever those arguments are. This constructor here doesn't do anything at all. So if I were to create a rectangle object here in my main class that has my main method in it, this is a separate file, right? Object practice. When I say new rectangle, these parentheses here, this is another way of saying, this whole thing right here is another way of saying call the constructor of the rectangle class. So right now, I'm calling the constructor that has no parameters, right? This one here. So the rectangle will be created, it will have a length, it will have a width, and it can use all of these methods, but these fields are empty. If I use my other constructor, oh gosh, clicking everything. Can we call these parameterized constructors, constructors that have parameters? My parameterized constructor had a length and a width parameter variables, right? So I can pass those in here when I create this new rectangle. So let's say my length is 15 and my width is 5. And we'll see IntelliJ is actually smart. It's going to tell us the name of these parameter variables that we're actually storing these arguments in. So those are our 2 kinds of constructors that we use. The difference is, let's say I want to print out the length of rectangle 1, right? Notice rectangle 1 uses the empty constructor. I did not want to debug that. We'll see that the value is 0, right? Or null. There's nothing in that constructor. Or nothing in that length field, right? Length is empty. Let's say I want to print out r2.getLength. Right? R2, we use the parameterized constructor which said set the value of our fields equal to whatever is passed in. Right? So R2 has a length of 15, right? And that should show. So R1 has not set its value, R2 has. And we can say that it has because of our constructor. So let's hop back over to UML. How do we show constructors in UML? Like I said earlier, I typically show them just like any other method, but I do not list a return type. So back at my diagram, I want to add in my constructors. So my first constructor was public rectangle. It had no arguments, and it didn't really do anything. My second constructor was called public rectangle. It had 2 arguments. It had a double named len, and it had a double named w. Notice I'm not putting a return type after this one because it is a constructor and it does not require one. So this is a complete UML of the rectangle class that I have been showing the source code of. We have a concept of a default constructor, and the default constructor is something that is created automatically by Java if we don't write a constructor ourselves. So if I did not include this constructor here or this constructor, Java would automatically create a constructor for me that looks just like this. It didn't, obviously, because I wrote it myself, but if I didn't include these, Java would create one that worked just like this one. So we can write our own default constructor, or if we have no constructors at all, Java will give it to us automatically. And I will go in and comment this a little more heavily before I upload it. But the default constructor does not accept any arguments, and it sets all numeric fields to 0, and it sets any Boolean fields to false. If any of our fields are reference variables, like strings or anything like that, it would set them to null. The only time that Java will provide a default constructor for us is when we don't write any constructors at all. But like I just said, we can write our own default constructor. It just doesn't do anything, right? It has no parameters and nothing inside the braces. And if the braces being on the same line is like weirding people out, we can say it like this just as easily. All right. Obviously, there's no questions that I'm going to receive right now because this is on YouTube, but I am going to move into the part 2 of the classes and objects discussion. Okay. Before I move into the part 2 slides, I want to show you how we can use a UML of a class to actually write the code for that class. So I have a UML here for a class called movie. We can see that the movie class has 3 fields: title, year, and budget. They are all private. Title is a string, year is an int, and budget is a double. I also see that we have the following methods. We have a constructor here that contains these. I'm actually going to add one more. Actually, no, I'm not. We have a constructor that asks for a title, a year, and a budget. We have a getter for each of our fields. And we have a setter for each of our fields. And I also have a method here called toString, which I'll probably come back to later in the discussion. So we'll come back to this one later. But using this UML, it's actually very simple to set up the basic structure of a class. So if I go here to IntelliJ, to my source folder, I'm going to add a new Java class. It's going to ask for the name. I'm going to call this class movie. We know that movie had 3 fields, right? Title, year, and budget. They're all private. So I have private title, or private string title, sorry. Private int year, and private double budget. And I'm getting my data types from the UML as well, right? String, int, double. So my fields are all done. Now if I want to add my methods in, I had a constructor, right? Remember, constructors always share the name of the class. So my constructor will be movie. So I will say public movie. Again, constructors do not have return types. And the constructor that I want to use in this class is going to ask for a title. I'm just going to call this T. All right, so T T, Y, and B for title, year, and budget. And all I want to do is set these fields equal to whatever the arguments are. So if I create a new movie object and pass in, a movie title, a year, and a budget, I want to set the fields of that object to whatever I use in the method call. So title will be assigned the value of the argument T. Year will be assigned the value of the argument Y. And double will be assigned the value of B. Not double, I'm sorry. Budget will be assigned the value of B. So that's my constructor. I have getters for each of my fields, and I have setters for each of my fields. And those are easy to write as well. I can say public, and with getters, our return type is always going to be whatever the data type of the field we are getting the value of is. So if I'm writing a getter for title, my return type needs to be title's data type, which is a string, right? So public string get title, and all I'm going to do is return title. I'll do the same thing for each of my other fields. So I had a year, and year was an int, so my return type for this method is also an int. Budget was a double, so my getter for budget needs to be a double. Okay. Now for my setters. Setters are all void, so public void set title. But whereas my getter does not have parameters, our setters do, right? We want to set the value of these fields to some argument, right? I want to set the title to something else. I want to set it to whatever I pass into this method. So we need to create a parameter for that. Title is a string, so my parameter needs to be a string. So we'll say the value of title is changed to whatever the new title is. I'll do the same thing with year. Year is an int. The value of my year field is going to change to whatever the argument value is. I'll do the same thing with budget here. Budget is a double. Right? And all I used to create this very simple class was this UML, right? The UML told me everything. It told me that all my methods were public. It told me what their return types were. It told me any parameters that I was going to have. And I am I'm leaving out this toString for now, but I will come back to it. So it just kind of shows you how to create a class from a UML. So let's go back to the slides here. Let me pull this up from this slide. So this is like the second part of classes and objects. The first part was kind of a basic introduction. This part will go a little bit more in depth than the first part. And this is a lot shorter too. Method overloading is a concept that is very, very simple in essence. Two methods in a class can have the same name as long as their parameter lists are different. That's all overloading is saying. So in rectangle, my constructors are both called rectangle, and you may have noticed that when I was talking about it and wondered why is this not considered an error? Well, it's because we're using method overloading, which means they can have the same name as long as their parameter lists are different, right? This parameter list on this constructor is not the same as this parameter list, right? They are different, so this is totally legal. It works. It is important concept because sometimes we need several ways to perform the same operation. We most commonly use method overloading with constructors. Let's talk about the scope of our fields, right? You may be wondering, we talked about variable scope I'll go here. If I were to create another method down here, if I create another method here in my file with the main method, we know that variable scope says the scope of a variable is restricted to the method in which it is created. So R1 has a scope of the main method. It cannot be used outside of this method, right? So if I try to say R1.getYear here, or R1.getLength, it's not going to work. It's going to give me an error. It's going to say, I don't know what R1 is, right? And that's variable scope. Fields are a little bit different than variables, right? Remember, the rectangle class is describing rectangle objects. So these fields here are not the same thing as a variable. Fields, even if they're private to outside classes, are always accessible by any method inside of this class, right? Any method I write can access length and width, which is why I'm able to just set their values like this and access their values, because they're kind of globally available to all methods in the class. Any instance method in the same class as the field can be accessed by the method. If an instance class is declared with a public access specifier, it can also be accessed by code outside the class. And this should say field, not class. If an instance field is declared with a public access specifier, we can access it by code outside the class. Again, we don't really want to do that. We want to restrict the availability of the fields only to these methods. And then the methods can take care of giving the values to other files. There's a concept called shadowing, and that's when we have a local variable or a parameter variable with the same name as a field. And shadowing just simply means the parameter variable or the local variable name shadows the name of the field. It's hidden. So an example, set length here. Let's say I declared a variable called length inside my setter, right? Well, this is going to cause some shadowing issues because my field is also called length, right? What's going to happen here, Java is not smart enough to say, when I say length receives len, it's going to assume that I mean this length and not the field length. So that's what shadowing does. It can be a tricky bug to deal with because it's not going to throw an error necessarily. Your code will still compile and function, but it is something to watch out for. So for example, I'll go back to movie. The reason I made my constructor variables T, Y, and B instead of title, year, and budget, when I say title receives title, right, that looks odd, doesn't it? And that's because of shadowing, right? I know that I want this title up here to receive whatever this parameter title is, but Java doesn't know the difference, right, because their names are the same. So that's why you need to be careful with that shadowing concept. We've discussed this already. We're not really working with packages in here, but we know that import statements are a thing, right? We import the scanner class. We've already said we don't have to import classes that we write ourselves, but just something to note about importing. What an import statement really does is it tells the compiler which package or which folder a class is located in. So for this right here, the scanner class is located in the java.util package or folder. If we didn't have this statement, the compiler couldn't locate the scanner class. We do have two types of import statements, an explicit import statement and a wildcard statement. An explicit statement identifies the package location of a single class, and this is what we're most used to seeing. Import java.util.scanner, import java.util.random, import javax.swing.joptionPane, right? We've seen these explicit statements. Wildcard statements tell the compiler to import all classes in a package. And a wildcard statement is just a star at the end. So if I say import java.util.star, it will import every class in the util package, including scanner and random. So that's another kind of import statement we could use. Using a wildcard import statement actually does not affect the performance of your program either. That's maybe a concern. If you're importing more than you need, is that going to affect the performance? It does not necessarily affect the performance. The java.lang package or java.language package is automatically imported into every Java program. This is how we're able to use system.out.print without importing system, or how we're able to use string objects without importing the string class. These are so fundamental and common to the Java language that it's automatically imported. Some other Java API packages that are kind of useful. Java.io lets us perform input and output with files, like text files. Java.language we just discussed. Net is like network communications. Security, java.sql, java.text, java.util. We've seen java.util provides various utility classes, right? So something I want to show you to make this kind of more understandable. I may zoom in here a little bit. What we've been discussing about classes is nothing really new. This is the scanner class. This is the source code of the scanner.java file. So every time we import scanner, like I said, it's in the util folder, java.util.scanner, right? We can see the path here. This is on Java's official GitHub. I'm looking at the actual scanner class. Whenever we import scanner, this is what we're importing. We'll see that we have, oh, this is something else. Hang on. Okay, sorry. Up above was some display purpose things that they were using. But right here, there's some more extra stuff than what we've discussed, but we can see that it's basically the same, right? Public class scanner. And we're not really going to mess with any of this other extra stuff, but public class scanner. We'll see we have our fields, right? All of these fields, private int position, all of the stuff. These are our fields. All of these fields, right? Fields, methods, it's exactly the same thing as we discussed. Here is a constructor, private scanner, right? Here's another constructor. Here's another constructor. Here's a method. So we could go down through here and see, this is kind of the same thing we've been discussing. Obviously, it's a little more complex than the class we just looked at, rectangle, which had like 4 methods in it. But the concepts are still the same, right? And the reason that we import scanner and don't import rectangle, for example, rectangle is in the same folder as my class with the main method. The scanner.java file is not in this folder. That's why we have to import it. That's the only real difference. The last thing I want to discuss is the toString method. And the toString method essentially says, how do I want my objects displayed as a string? And that might sound a little weird, so I'm going to show you what I mean. So I've created this movie class, right, from the movie UML. It had a title, a year, and a budget. It had getters, it had setters. Let's go back to where my main method is, over to this file. I'm going to create a movie object. Right, the first thing we needed was a title, which was a string. So I'm going to put the title in quotes. And I can't think of a movie off the top of my head. It's Halloween night, so let's do Halloween. All right, I had to look up the year and the budget for Halloween because I have to be correct. So we have a year of 1978 and a budget of $325,000. I think. Let me make sure. Yep. So our constructor, right? We're using our constructor right here. The first thing it needed was the title, the year, and the budget. And then whenever this object is created, it's going to set these fields equal to these values. Okay. So what if I wanted to display my movie as a string? What if I wanted to print out movie 1? This is what will happen. This is actually printing out the memory address of the movie object. It's telling me that movie 1 references a movie object at this location in my RAM. Right? That's not really what I want. Maybe I want my movie to be displayed a certain way, right? We can do that by using a toString method. That's kind of what they're for. So this is going to be a public string, toString. And all we do with the toString method is we say there's several ways you could write a toString method, but this is kind of how I'm gonna do it. I'm just gonna build up a string here. So maybe the first thing I want displayed in my string about a movie is the word title, followed by the title itself. Oops. Right, and I want a new line after this because I want each of these things to be on its own line. Maybe the second thing I want displayed, and I'm actually just going to copy this line of code up here. Maybe the second thing I want displayed is the year. And the last thing I want displayed is the budget. And with a toString, we have to return the value of movie string at the end. So back over here, I'm not changing anything in this class. I'm still going to print out the value of movie 1. But now we can see that it used my toString instead of showing me that memory location. That's what a toString method allows us to do. And I could get even more detailed with this and say, you know, I want my budget to be displayed a certain way. Right, we've discussed how to format decimals and all that. Maybe now I want my budget to have dollar signs, commas if necessary. and we can show that. That's what a toString allows us to do, is display objects as a string, or it converts an object to a string, basically. It doesn't convert anything, but it kind of displays an object as a string. So that's really the last thing I wanted to discuss. So quick recap, classes can be used to create objects, right? And all a class is a blueprint that describes what an object is going to look like. It describes two things: any data that the objects can hold, which we call fields, and these are our fields here. Any actions that the object can perform, which are called methods. And we also can create things called constructors in our classes that define how new objects are constructed or made. Constructors share the name of the class. They do not have return types. Fields most often are private. Let's see, what else can we recap really quick? We don't use the static keyword in classes that we are going to use to create objects, right? We are creating rectangle objects. I don't want the static keyword here. Also, I didn't mention this earlier. Notice we don't have a main method in rectangle. I don't have a public static void main. That's good. We don't want that here. All this class is doing is describing what objects are going to look like. We can leave the main method in another file and create rectangle objects. How do we create objects of classes that we wrote? Well, as long as they're in the same folder, right? All of these are in the source folder. As long as they're in the same folder, we just give them a data type of that class. We give it a name, and then we create it. And depending on, how many constructors we wrote or what the constructors look like, we could pass in values or we could not pass in values. That's up to the constructors. Then, like it shows down here, we can display the object as a string if we include a toString method. We can use setters or getters to change the value of these fields. All by using the reference variable name. So that's a quick recap. I probably won't be having you create too many complex classes quite yet if we do at all. The main thing I want you to be able to do is, can you look at the source code of a class and create the UML? And remember that the UML syntax is very particular. So minus in front of the name means private, plus in front of the name means public. Then we have the name of the thing. For our fields, we don't put parentheses. For our methods, we do. After our field names, we put a colon followed by the data type of that field. After our method parentheses, we put a colon followed by the return type of the method. Any parameters follow the same kind of convention as our fields. So we have the name of the parameter followed by a colon followed by the parameter's data type. Constructors in UML do not have a return type. It's kind of the basics of UML. I will post this UML here as well as the slides that describe how they're made to D2L. So for the main things I'm concerned about and assignments that we may have, can you look at source code and create a UML? And then on the flip side of that, can you take a UML and set up a very basic class, kind of like we did with movie? And the other thing I want you to be able to do is look at an existing class, be able to create objects of that class, and use that class's methods. Next week, we will probably talk a little bit more about this, and I will introduce the idea of collections, probably next week.